Alright guys, so this is a quick review on the scientific method. Alright, so we know the scientific method is a system of knowledge about how, basically a system of knowledge, and it is basically the methods that we use to find that knowledge. So it typically begins with curiosity, so people asking questions, and often ends with discovery, so things that we learn from it. So we remember the steps of the scientific method: making observations or asking questions, researching slash whatever scientific knowledge you already bring to the table, forming a hypothesis, creating a procedure or method that you will use to test it, collecting data from that procedure or that experiment, analyzing that data in the form of graphs or words. Conclusion is typically finding the information and analyzing it until you have come to an answer to your question, and then finally sharing your findings. So making an observation or asking a question, it's something we notice about, it starts with you noticing something about the world around you and being like, oh wow, that's interesting. I have a question about maybe how that works. Scientific questions should always show a cause and effect relationship, so we're looking for the relationship between two things. So they're often asked in the form, how will the whatever you choose for your independent variable affect the whatever you choose for your dependent variable? So in our example here, okay, I've got a bunch of tulips and it says, I see the tulips are growing very well. I wonder which kind of fertilizer can make the tulips grow the tallest. Well, my scientific question would be, how will the type of fertilizer that a tulip is grown in affect the height that the tulip grows? So we have our independent variable, which is the height of the fertilizer, and our dependent variable. Typically when we ask a question, we either already come to the table with some information we already know, or we need to research a decent amount. We want to gather information that relates to the experiment. Obviously you don't want to be researching roses when you have an experiment on tulips, because it won't really help you too much. You can always, when you're doing your scientific research, you can use the class discussions, any vocabulary that you've put in your glossary or just have used throughout your interactive notebook, your textbook, your internet, any handouts that I've given, or any prior knowledge that you already bring to the table. And typically in your lab you will write your research in the form of a paragraph. So no like bullet points or anything, but a full paragraph on what you already know on the topic. So this might be an example for the example I gave last time, which would be, I already know that tulips need a lot of nitrogen in the soil to grow well, as well as plenty of light and water. I found out by reading Tulips Monthly that they also need a lot of phosphorus in the soil as well. So that might be something that I include in my research or scientific knowledge paragraph. Hypothesis or testable prediction. So it's a prediction based on research. So basically now that I've researched and I have all my scientific knowledge organized into a nice paragraph, okay, I can use that in order to make a educated decision on what I think will happen when I try to answer my testable question. It should always be written in the form of if, let me move this, if the independent variable is however you think it is going to change, then the dependent variable will however you think that is going to change, because, and you want to explain this based on your research or knowledge. So in my example is, if a fertilizer has relatively high concentration of phosphorus and nitrogen, then the tulip will be able to grow taller, because based on my research, tulips grow the best in high phosphorus/nitrogen environments. So procedures and methods. Okay, we know that we will always list materials that we're using, including the quantity, so how much of it you need. And you always want to include safety devices. Anything that you're going to need to keep yourself safe or to do the experiment is included in your materials list. You also want to have you want to list the steps that you're going to take in order to complete the experiment, and you want to put these in pretty decent, like you want them to make sense. You want them to be in good technical writing, like using your good technical writing skills, because if someone else tries to do the same experiment, they need to be able to follow your steps, which means it needs to make sense. You want to identify your independent and dependent variables so people are very well aware of what you're testing in your experiment. You also want to identify any controls, control groups, or constants that you have. Also, you want to identify the number of trials. So if you're going to repeat this 3 times and take the average, I need to know that in your procedure or your methods. Data. Finally, you want to write out the information you get. So you're going to do the experiment following your procedure, following your methods, and you're going to get experimental results. And this is typically data. It can either be in the form of numbers, which we'll get to a lot this year in 8th grade, or it could be in the form of qualitative observations, which are a lot, they're not from numbers. So if we remember, qualitative observations include words, colorful pictures, illustrations to describe what happened, whereas quantitative observations include numbers, measurements. They're very rigid. You can usually make a table, a really good table out of quantitative observations, whereas sometimes qualitative, they have to be really big so that you can draw on them. Data analysis. So when you are done with your experiment and you're now just looking at your data, okay, you want to analyze any trends. So maybe as the independent variable increases, the dependent variable decreases. So you want to look for those trends. You also want to take any averages, especially if you did trials. So if you did multiple trials, you're going to need to average all of them and come to some sort of like conclusion on what you think the average number is and what you can use for your conclusion. You want to do rankings, figuring out which situation was the best, which was the worst, which came in the middle, and in which order. And then when you're creating your graphs, which you will do under data analysis a ton, you want to make sure you're doing the ICATS graph, where you make sure that it is taking up a decent amount of your paper and there's a good scale and all that. I'm sure you guys remember that from math. You guys do that all the time. So finally, you would write a conclusion. And in your conclusion will be these 6 things. You're summarizing the purpose or the question that you were trying to answer, and you're outlining any major findings that you had. So just basically interpreting your data, saying A happened, therefore B happened. It looks like, according to my data, that that is supported. And then you also want to say, well, my data either supported my hypothesis or maybe did not support my hypothesis. Whatever happened in your experiment, remember, either is okay. It doesn't always have to support your hypothesis. You don't have to be right. And it's totally acceptable to be wrong, because we learn just as much from being wrong, if not more, from being wrong than we do from being right, or at least from having our hypothesis supported. Discuss where there might have been some mistakes, maybe where you and your group didn't work well together, or maybe someone misread something, or maybe a tool might have been off. You want to analyze all the different areas where these little mistakes might have happened. You want to explain how you might improve your experiment next time. So if you were to do this all over again, what might you do differently that might allow you to get more accurate or precise data, or another experiment that you might want to test based on your conclusion for this experiment. You also want to describe or summarize how learning by doing the lab relates to real life. So give me an example of how your lab, the one you did, actually could benefit somebody watching this who isn't just in science class, how it might benefit the real world or mimic real life. So yeah, that's basically a really quick rundown of the scientific method. I hope you all understood and that you all took really good notes, and I will see you tomorrow in class.